So to start, what is meant by elemental analysis?
Well, typically it means in general that we identify and quantify the present elements in the given sample. So we want to figure out what kind of species and in what kind of quantities they or concentrations they are in the sample.
Okay, and when would you need to perform this?
It depends on the cases. So usually it relates to some sort of quality assurance and quality analysis, and then troubleshooting, and then obviously some purity assays on different, for example, chemicals. Some of the purity assays are conducted in a way that the impurities are basically quantified, and then the rest is expected to be the chemical of the given sample. And then obviously some of the processes depend on producing products that have very specific amounts of elements in them. So obviously the process can be optimized based on the different elemental analysis.
So what are some typical like standards or like reasons to do testing? Are there like legal requirements, for example? Or?
Not necessarily legal requirements. Well, there are legal requirements. Some substances are restricted, or then they have high risk. For example, heavy metals are analyzed from various consumer products, and some of the analysis is done with for example, with ICP. So we want to analyze that we don't get consumer products containing, for example, mercury, cadmium, lead, and hazardous elements or metals in them. So we want to make sure that there isn't any harmful chemicals in them. But usually some of the companies have their own internal specifications for their own products, not necessarily for the legal reasons, but simply because their own quality standards, they want to have higher standards than what is basically required by the law. So they can actually say that we have this, this quality and very high internal quality specifications to fulfill the consumers or the customers' needs. And obviously some of the contracts may even have consumers coming from the consumer or customer sides, even more strict requirements for the product quality, and it may require, for example, elemental analysis. Some of the fuel industry actually uses and utilizes for example, the kind of elemental analysis from the fuels, so that there isn't too big quantities of different elements. Sulfur is one of the example, and basically sulfur-free or low sulfur products has been developed in the last 30 years, if I remember correctly, and now the bunker fuel or the maritime fuel industry is going to more to the sulfur-free and low sulfur fuel side in order to provide more or higher quality products, and the kind of products that don't basically create any harmful burning gases and flue gases coming out of the chimney and the exhaust pipe.
Okay, which methods would you use?
Well, the list is quite long, so I probably cannot give the exhaustive list, but I would use ICP with various kind of detectors, then AAS, CHNOS, XRF, SEM-EDX, ERDA, RBS, to name a few. So, but the list is quite long, and probably there are some techniques that I'm not too familiar with, so I won't go into the too detailed discussion about those.
So what would it depend, the method choice? How would you decide?
It depends on the matrix, then obviously how sensitive method is needed for the analysis, and then what kind of information are you looking for. So some of the techniques give the bulk amount of elements in the whole sample. For example, typically in the ICP methods, you dissolve the whole sample and then analyze the solution and that gives you the overall concentration of the elements in the whole of the sample. But some of the techniques are surface specific, so you can analyze the surface of the sample and provide the elemental information from that. Some of the methods have basically ability to go deeper beneath the surface by sputtering out the layers of the sample, so you can create a depth profile of the elemental composition of the sample. So it depends basically on the end need, how you would require or how you want to use the data that the analysis provides.
Is there some like general rule for when you would rather dissolve the sample or when you would want to use this kind of not so destructive method?
I really don't have a specific definition in mind. Usually when the sample can be very heterogeneous, so that it consists of different kind of, well, not pieces, but parts of the sample, then the use of ICP and the bulk elemental analysis is very useful, because if you analyze small section from the surface of the sample, then it might give you a very biased view of the overall elemental composition, and you would need to conduct multiple different or the analysis from multiple different spots with the surface specific methods, and that would take more time, and most probably it would be more expensive. Plus the data analysis would be, well, cumbersome in the end, because how do you know what is the correct spot basically? So if you get two different kind of results from the surface specific method and three other kind of results, then obviously you can average them out, but you don't really know what is the real composition of the sample. So in a way, that kind of situation, the bulk analysis would be more helpful.
And does the choice of method kind of depend on the industry as well? Are there like specific methods specific?
Yes, typically the ERDA and SEM-EDX, and well, I don't know if they're more sophisticated ones, but the more surface specific analysis are used in microchips and semiconductor industry, because, well, they usually utilize the kind of materials that are well suited for this kind of analysis, and the methods provide sufficient information for those purposes.
And then what about like ICP? Where would you use that?
ICP is, well, it can be used in a very broad spectrum of different categories of analysis. So basically, if you're able to dissolve the sample, then you can use ICP. But ICP has a very good sensitivity depending on the sample matrix and the given element. So you can go in a very, very low level of quantification of different elements. So even PPT level is achievable with the ICP, whereas with other methods, they tend to be not so sensitive, so you wouldn't get the information from there. But ICP is typically, if you don't have anything on your mind, then most probably ICP is a good candidate to start with.
Mm-hmm. Can it detect all elements, or are there some limitations?
No, it cannot detect all elements. So it was from oxygen onward, the ICP. But the lighter the element, the harder it is basically to analyze. So I guess ERDA is the only equipment suitable for hydrogen analysis or quantification of hydrogen directly from the sample. Obviously, you can utilize CHNOS analysis, which is basically burning the sample, but it's more suitable for the organic sample. So the sample should burn. But if you have some sort of metal hydride substrate, then obviously you cannot burn it. So you have to use ERDA for the analysis.
Okay, so would you decide the correct method depending on if the sample is organic or inorganic, or does that affect?
Yes, it does. So basically, the elemental analyzer is mostly for the organic substances. Then ICP can be used for the organic substances, and then XRF can also be used. But for the inorganic parts, then you could use AAS, XRF, SEM-EDX, ERDA, and Rutherford backscattering, and ICP as well. But well, there is no strict line what method you can use for the organic and inorganic materials. Some are only available or applicable to organic materials, and some only for inorganic materials, depending on their spectrum of elements that they are able to analyze.
Would the results be qualitative or quantitative with each of these methods, or does that depend on the method as well?
Usually they are both, so they are able to identify the substances or the elements and then quantify them. AAS is basically on the borderline. I wouldn't say that it's necessarily able to give qualitative information. At least on my experience, you have to basically prepare the calibration curve using this kind of known sample in order to provide enough information for the machine to detect the element. But yeah, it's on the borderline, but I would still say that the AAS is also qualitative and quantitative method.
About the detection limits for different elements, so can you kind of categorize these methods in terms of what is the most precise?
Yeah. Well, this was a quite challenging question, because I started thinking that, okay, can I categorize them? Well, yes, in a very, very general level, and obviously it depends on your sample matrix, the element that you want to analyze, and the overall equipment setup. Overall and in general, I would say that the ICP is the most accurate, and then the least accurate would be probably SEM-EDX and elemental analyzer, and then everybody else in the between. And this listing and the categorization basically only includes the methods that I have listed earlier. So there might be some more accurate and less accurate methods than I have listed, but I would say that the ICP is would be the most sensitive and reliable way of analyzing the elements.
Okay, so what do you need to know about the sample to be able to make the appropriate method selection?
Well, basically, what kind of information the customer is looking for. Do they want the bulk composition, elemental composition of the sample, or just from the surface? Then optimally, it would be good to have a general overall idea what the sample is. Obviously, we can analyze or try to analyze the unknown samples as well, but the better description of the sample that we get from the customer, the more suited our suggestions are for the given sample to be analyzed with, where the information will be used, and if there is some specific standard method that we should use, or even if it's available, or if we should basically develop a new method for the customer.
Okay, so what would you need to take into account when you sample for these analyses?
Well, the most important thing is not to contaminate the sample with by your own hands or the sampling container that you take them into. I have heard one of this kind of more experienced colleague in the field that you will get contamination from the mini grid packs if you packed your samples in them, simply because there might be some silicon residues that will show up in the analysis, and that's something you should be, and the customers should be aware of, that how do they want to pack their samples before they send them to analysis, because then we can avoid the situation that the analysis shows a huge amount of some elemental impurity, and if we don't know where it comes from, then it's kind of tedious work to find out and figure out what is the root cause for the impurity. But packing the samples appropriately is one thing, and then obviously getting a representative sample of the whole material that you want to analyze. So for example, if you take a sample from the table, it doesn't help if you take a sample only from the wooden part. You would need to have some sort of average of the whole table, including the metal and the wood itself. So you would probably have to crush the table and homogenize the whole powder, and then provide the sample to the elemental analysis in order to get the representative results. So the sampling is very, very important, and handling the sample is very important.
How much sample material would you need? That depends on the method.
Well, it depends heavily on the method, but I guess the highest amount that we require is XRF. We are talking about tens of grams, so not a too big of a quantity of material, but some of the ICP methods require only like 20 milligrams of sample, so it can be done from a very small amount of sample as well.
So you talked about the kind of preparation. How much preparation do each of these methods kind of require, or like which are the most complicated ones to use and which are?
When considering the basically sample pre-treatment, some of them are, if the sample is basically, well, if it's suitable directly for the analysis, some of them can be provided as a single unit of sample, and then it can be analyzed. Obviously, in some instances, for example, in the ICP, it requires quite heavy pre-treatment for the sample in order to get it in the form that it can be analyzed. So basically, it needs to be dissolved in water or acidic water solution. And then, for example, if you want to analyze gold, gold is quite hard to dissolve, so you need to use aqua regia, and that requires, well, quite heavy pre-treatment. And also different kind of silicon dioxides, they don't dissolve basically in any other acids besides hydrofluoric acid, which then again is, well, work safety wise, it's not the most optimal acid to be used in the laboratory.
And how long does it take to get results? It probably varies between the methods.
Yeah, it varies
the
between the methods, but I would say from 3 to 6 weeks in general. And some of the analysis we do provide the rapid turnaround, so it might be as low as or as short turnaround time as 1 to 2 weeks.
And how would you rate the different methods? Like, which are the more expensive ones and which are like the cheaper ones? If someone wants to kind of choose between two that could work and wants to make like an economical choice.
Yeah. I don't know exactly about the inorganic elemental analysis prices or the equipment and method prices, but ICP methods, depending on the detector, they can be rather, let's say, cheap, because they are so routine analysis, and they can go as low as 50 to 100 euros a sample. And then elemental analysis is also in that same category, a couple of €100. But if you have a very exotic sample matrix for the ICP analysis, and the pre-treatment is very hard, then the sample price can go very, very high, close to 1,000 euros per sample. So the variation is quite high, depending on the sample matrix and the required elements and the information you want to get out of the analysis.
So if we're summing up this discussion, what would be like the most kind of important things or how to get started when someone is looking to get an elemental analysis of their material?
I would say that the description of the sample matrix as in as detailed manner as possible, that is very important. Then obviously understanding of how to take this representative sample and how to and where to store it and how to pack it in order to send it for the analysis. And then if you don't have a proper understanding of the techniques, then perhaps it would be a good idea to give as detailed explanation and background for the need of your analysis, so that the expert can actually decide or suggest the different methods for you. But obviously there are many experts in the field who absolutely know what they want. So basically they can then just say that, okay, we want RBS and ERDA analysis done to this sample, and that's it. Then we can rely that the customer know what they really want. But if you don't have a clear understanding or clear view what you would like to use for the analysis, then obviously it can be asked, and we can suggest the different methods depending on the need.